All right, so in the last two modules, we've looked at sequence data structures, tuples, and lists. And we're kind of rounding out this set of modules on data structures with the dictionary data structure, which is built into the Python language. And dictionaries actually are tremendously useful. They're very, very flexible and very powerful, but they have some very distinct differences between lists. Generally, they fulfill a different use case than tuples and lists do. And incidentally, they are not sequences. Remember, the definitions of a sequence is an ordered list of items or an ordered set of items. And that's something that a dictionary actually will not give us, but it'll give us some additional functionality. So let's look at what the key differences between dictionaries and lists in particular are. So lists and tuples store objects that can be accessed via an index, right? And so we've seen indexes even back to module 2 when we started talking about strings. Indexes are innately positional, right? So index 0, we know that that always comes before index 1, and index 1 always comes before index 2. So indexes are integer values that represent the position within an ordered list. Dictionaries are very different. So in Python, you can create a dictionary with the dict function. So if we remember, we can do list equals, let's not do that. Let's say x equals list. If I want to create a dictionary, I can do dict. So a dictionary is a lookup table, all right, which is fundamentally different than a list of items where you can iterate through a list, you can search for something. In a dictionary, you are looking things up. So this is where a lookup table is where an object can be retrieved by an index, and it can, by the way, also be set by an index. But the indexes are not positional. There is no inherent order of objects that is contained in a dictionary. Indexes can be of any type, and that's vastly different than a list or a tuple where indexes must be an integer value. They represent a specific location inside of a set. Dictionaries don't have that notion. Indexes in dictionaries, because they're so different, normally we don't really call them indexes, we call them keys. Right? So we can access elements or pieces of data or values using a particular key. So a dictionary is also called an associative array or a set of key value pairs. So let's just see a simple example. And this dictionary is being used to sort of associate strings or month strings with numbers, and it's actually providing a a two-way set of associations. So first, let me just point out what's going on here. I've created a variable. Remember, a tuple had a parentheses. A list has a bracket, the square brackets. A dictionary is represented in the literal form as or with these curly braces. Right? And so these curly braces are delimiting the dictionary, and inside that contains a series of key value pairs. Right? So they're each separated by a comma. And so the left-hand side of this colon is the key, January, and the value is 1. So that's basically saying for the string Jan, that's month number 1. For the string Feb, that's month number 2. For the string March, it's month number 3. So the key is a string for these particular key value pairs inside this dictionary. But in addition, I also have some key value pairs where it's the other way around, right? So there's a key value of 1 corresponding to the string January. And there's a variety of different ways to represent this association. This is just one particular example. So I have this kind of chaotic diagram over here, but what I'm trying to represent here is that there's no implicit order. You can almost think of this as sort of like a cloud of keys existing within this dictionary. And if I am to look up, the key January, that's going to give me the value associated with it, which is somewhere else in memory. So there's no inherent position to this. We can just look up via keys. So January associated with 1 is being represented here. All right, so we've got our key January and our value 1. If I want to retrieve that, or if I want to overwrite it, for instance, I can use the square brackets. So remember, anytime that you want to manipulate a list, right? So if we had a list, if we wanted to manipulate the second element, we would just say something like that, right? Well, notice the correspondence here, right? So if I want to change, or by the way, set a new element, I can use the square brackets. The difference here is that this is a string. This could be any data type. The index is of any type. So if I was to say month numbers Jan equals ABC, that's just going to look up this key, and it's going to change this key to point to the string ABC instead. If I was to do something like this, right, that would actually create a brand new key called DEC for December and associated with the number 12. All right, so you can add things to a dictionary just by basically assigning a key value that doesn't already exist. Before I move on to that, we can also retrieve values. Right? So right, so if we want to print out the number, or in this case the letters associated with the key January, I can just write it like this. So we're kind of moving quickly here because there's a lot of shared syntax. So to access and to overwrite individual elements within a dictionary, we just refer to the same indexing syntax as we use with lists. The difference now between a dictionary and a list is that the indexes themselves are not positions. They could be anything. And again, they could also be 1, right? And that would correspond to this particular key pointing to January. You can, once you have a dictionary, you can iterate through a dictionary just like you could iterate through a list, but it's a little bit different in that when you do your for loop, you can't just do key in month numbers and it's not a key value pair that gets returned. It's actually just simply a list of keys. All right, so when you do for key in month numbers will return back, will be iterated through as a list of keys. And if you want to access each individual value within it, you're just going to, you can use the key and then you can access the key using the indexer. So that's, I've only gone through a very small number of slides and I haven't really delved into a lot of details of using dictionaries. Dictionaries are very, very common because they're simple. They just allow you to store a piece of data associated with a key, and they are very, very versatile. So we'll use dictionaries a lot. They're used in all sorts of programs. Very, very helpful, but actually very, very simplistic. There isn't much more to a dictionary than this. So would recommend that you immediately kind of start looking at the programming exercises where we're going to use some dictionaries, and a lot of times where we'll use dictionaries instead of lists where we have to do a lot of information retrieval. Dictionaries aren't iterated quite as efficiently as lists. So if we know that we're not going to be doing a lot of lookup, but we're going to be doing a lot of iterating, accessing every single value within a collection, a list might be a better alternative. But if you find yourself constantly searching a list for a particular thing, you probably want to start thinking maybe this should be a dictionary and support a lookup directly so you don't have to write all that additional code.